sketching a curve from a description. Okay, so in this lesson, what we're going to be doing is we're going to be, well, what it sounds like, we're going to be sketching a curve from a description of the function. And by description, I mean we're going to be given some of these things that we've been looking at, right? So, you know, the first derivative, the second derivative, and where it's positive, where it's negative, that kind of stuff. So to begin with, we see that f of 0 is equal to 0. Well, we've been doing that forever, right? That's really the same thing as the point 0, 0. This is our x-intercept, or our y-intercept too in that case. But there you go. We know that this thing crosses right through the origin. Okay, the next part says f of x is equal to f of negative x. So that's telling us that we have even symmetry. And it's going to be even about the y-axis. All right. So now the limit as x approaches infinity of f of x is equal to 1. Okay, well, what does that mean? That means that as x is going farther and farther this way, okay, that means that we're approaching 1. So that means we have a horizontal asymptote at 1. Okay? Now, even though we can have other asymptotes too, right? Like we could have like a different one, but this one always just tells us that we have the 1, right? So I'm actually kind of assuming that this is plus or minus infinity as well in my mind, right? And this will kind of make sense with the rest of our picture too when we get going. But okay, so that's the case. So we know that we got that going on. Okay, so now the limit of f of x as x approaches 2 from the left is negative infinity. Okay, so 2 would be right there. And as I'm approaching it from the left, it's saying that I am going toward negative infinity, right? I'm going this way. This looks to me like we got another asymptote at 2. A vertical one this time. You know what? Sorry, I'm going to make that green line red as well. All right. So now, like I said before, we know that this thing will be doing this, right? So you can kind of lightly sketch those things in for now, and we'll kind of piece it all together when we're done here. Maybe I'll do something like that. Okay. All right, so that was the first part. And then as x, the limit of f of x as x approaches 2 from the right is positive infinity. Okay, so that means that we're going to be doing something like this. And you probably know that it's going to be approaching that horizontal asymptote that we already did too, right? Okay, so we got that one going on. Now it says f prime of 0 is equal to 0. So remember what that means, right? So the first derivative is telling us it's telling us the slope of our line, right? So it's saying where is the slope of this line equal to 0, right? Where is it totally flat? Well, it's totally flat when x is 0, okay? So what that means is right here, when x is 0, we're going to have a totally flat, or a totally, like no slope right there, right? So that must, like if this is the case, looking at this thing, right? It must be the case that this thing comes up, touches the origin, and then it's going to start coming back down again. You know, you can kind of piece that thing together as we go, like it must be the case, right? When we did this this first one here, well, like just when I looked at this part, all we really knew from this was that it was either a max or a min, right? I didn't know which one it was, but you know, based on the context of the situation, I can already tell it's got to be a max, don't I? Like a local max. But anyway, we'll keep going. All right, so now f double prime of x, so the second derivative of x is greater than 0, so it's positive, right, is what that's saying, where x is less than negative 2 and x is greater than 2. Okay, so then negative 2 would be there, right? Erase that thing. Okay, so it's saying when, so you will get a positive, right? So it's opening up, it's concave up, right? In this case, where x is less than 2. So what that means is it's going to be concave up in this section, right? And maybe by this section, I should cut to the chase here. Since it goes 2, -2, but not it actually it doesn't touch either, right? Like it's not including -2. Then we also know that this we're probably safe to think that this is a another vertical asymptote, right? So then in that case, yeah, we're going to be concave up, right? So it'd be something like this. Yeah, nice and concave up. And then it's also concave up when x is greater than 2. And yeah, I already kind of had that piece figured out over here, right? And then the second derivative of x is less than 0, so negative, right? So we're looking at concave down in that case, where x is greater than -2 and less than 2. So okay, so concave down, that's going to be this. That also verified that this was in fact a local maximum at that point, right? We knew that it was a max or a min, but that definitely in this case it was concave down after that. That was definitely a max. Now, the one thing I kind of just assumed here, right, was this asymptote, right? Like that, I guess, like from this information, it wasn't like totally obvious that that was the case, that this asymptote was right there, right, for -2. But let's look at the alternative, right? Like, so this was concave up, and that makes sense, and this definitely does make sense, right, with what we have going on. But just for a second, let's say that, well, couldn't it have been this too? What if it was like concave up like this, right, all the way until -2, right? So concave up, and then it switched to concave down. It was like flat there for a second, and then so inflection point, and then concave down. So maybe you're thinking, okay, that could have been the situation too, like if this was the case, right? But then the issue there, you can see that I'm not going to get this point here as a local max if I do that, right? A max or a min. That's not going to be anything. That's not going to, like the second or the first derivative wouldn't have been 0 there, right? So I know that this wouldn't have been the case. So it kind of turned out the only thing that it could have been was that this was an asymptote going up. So we kind of had to piece that one in, right? That idea there. Okay, let's try the next one. So let's start at the beginning. So sketch the graph of a continuous function. So we just know there's no gaps in between two, right? So it's continuous. And let's start at the beginning. So it says f of 0 is equal to f of 3, which is equal to 0. So another way of saying that is f of 0 is equal to 0, and f of 3 is equal to 0. There's two things here, right? There's really 2 points. You'd really have the point 0, 0, right? My x and my y, and 3, 0. Okay, so those are x-intercepts. So let's plot those. So you're going to have 0, 0, and 3, 0. Okay. The next one, we know that we have, well, again, these are points, aren't they? Again, so this is going to be f of -1 is equal to -2, and f of 1 is equal to -2. All right, so let's plot those points. So these points are at -1, -2, and 1, -2. All right, so -1, -2. So it's going to be there, and we have another one at 1, -2. So over there. Okay, next part. So it's saying the second derivative of 1 is equal to 0, and the second derivative of -1 is equal to 0, and the second derivative of 1 is equal to 0 as well. So what does that mean? Well, that means that we're going to have either a max or a min at those points, right? Because that's where the slope is equal to 0. So I know at 1, right? So at 1, we're going to have a slope of 0 there, and at -1, I'm going to have a slope of 0 there, right? So for now, let's just keep that in our mind, right? We don't really know if that's going to be like a maximum coming there and a minimum there, or if it's going to be looking like this. So we don't really know yet. So just keep that in your mind. All right. So then the next part says f prime of 0, or the second derivative of 0, is undefined. Okay. So what does that mean? So that means at 0, I don't have a slope, or the slope is straight up and down. So what could that mean? Well, there's two options. This thing, imagine this, right? It comes up, and typically if it just did like a curve and came back down again, then you might say, okay, well, that slope is 0 there. But what about this? What if it comes up and then comes to a sharp point and then goes back down again, right? If you remember, sharp points don't count because it has to be the slope as x approaches that number from the left and from the right have to equal the same number, right? So a sharp point would do it, right? That would give us an undefined. But you might be saying it would also work to have an asymptote there, which would be true, but that's not going to be our case for a couple of reasons. One is that it was said it was a continuous function, right? So we know that this thing doesn't break, so we don't have an asymptote in the way. And the other one is I knew that there was actually a point at 0, 0, right? So there's an actual point there, so there's definitely not an asymptote there. Okay, so this seems to me like it's going to be a sharp point situation. So let's write that in. So it'd be a sharp corner. All right. So keep that in mind too. And if you want to at this point, you can lightly sketch things in, right? Because I think we got a bit of an idea, right? Like I'm kind of guessing this thing's going to do this, come up, come to a sharp point, and then probably come back down again. But I could be wrong. We'll look at the other ones, but you know, that's a good idea. Okay, so for the next one here, it says the derivative of x is less than 0 on the interval negative infinity to negative 1, unioned with 0 to 1, right? So remember what this means. When it says the derivative is less than 0, right, that means we have a negative slope. That thing's decreasing, okay? So let's see if this makes sense with the current picture we have going. So from negative infinity to negative 1, this thing should be decreasing. And yeah, that kind of fits, doesn't it? So it's going down, 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 all the way to negative 1. Okay, so now one thing you might be saying is, well, what about this? Like we crossed the x-axis there, and we didn't have an x-intercept there. Well, the way these questions work, they don't give you all the information. There might be an x-intercept there. We just didn't have it, right? They just didn't actually tell us that info. Okay, so we'll just assume for now that there was, okay? So anyway, so that kind of fits with our picture so far. Now let's look at the other part of that interval. So from 0 to 1, it's also decreasing. So from 0 to 1, it's decreasing. Yep, definitely is, right? It's coming down in that interval. So okay, so far so good. The picture is looking good. So now the next one. So it says the derivative of x is greater than 0 on this interval. And that would be where the slope is positive, right? So where it's increasing. So if I'm looking at this one, just double checking with my little sketch I got going. Negative 1 to 0, it should be increasing. Yep, right? Negative 1 to 0, we're looking good there. And then 1 to infinity. So 1 to, well, I stopped it there, but you know, it's looking like it should be increasing, I guess, now forever there. Okay, so I'll lightly put this here because I know something else is going to happen in a minute. Okay, so we'll do that. Right, so now moving on to the next part here. So the second derivative. Now, we have a pretty good little sketch going here. We just want to kind of confirm a few things. So it's saying that the second derivative of x is greater than 0 from negative infinity to 0, unioned with 0 to 3. Now, the second derivative is telling us where this thing is concave up or concave down. So if it's greater than 0, that means concave up, right? So from negative infinity to 0, let's make sure that's true. So negative infinity to 0, yep, that thing is definitely concave up in that section, right? So perfect. Now moving over to the next one. So from 0 to 3. Okay, so this changes things up a little bit, right? So this is saying it's concave up from 0 to 3, which that makes sense. But then the picture I had before was kind of going up like this still, right? But that's not the case. If it's only concave up from there to there, then I'm really guessing this thing must turn around. It must start going concave down after that point. Okay? So let's look at the next section too to see if this makes sense. So it says it's f double prime, or the second derivative of x is less than 0 from 3 to infinity. Okay, that confirmed my intuitions there, right? That we're going to be concave down now going this way. All right. And now the last part says the limit of f of x as x approaches infinity is equal to 2. All right, so as I keep going farther and farther to the right, I'm starting to approach 2. So it looks to me like we have a horizontal asymptote at 2. So we're going to get closer and closer to 2 and never get there. Now, one thing to kind of go back on, remember it was increasing all the way to infinity? Now this one's kind of weird because by increasing you would think it would keep on going forever, right? Going up. But even though this thing keeps on getting closer and closer to 2, it is still increasing all the time, right? Little by little, it's less and less all the time, but it is increasing all the way to infinity, right? So that still works. Okay, and then the other half of this says the limit of f of x as x approaches negative infinity. Okay, so and that's equal to infinity. So that's the left side of the graph, and it's approaching positive infinity, right? So this actually fits with what I already kind of have sketched here, that this thing would go up and up and up forever, right? Never approaching anything. There might be a slant asymptote, but I'm not going to find that. So there you go. There's our sketch given this info. So I don't know. I find they're kind of fun. They're little puzzles, right? I have a feeling you guys are going to like them too. So